Hello, this is Jeff from Flywheel, and in this video, we're going to look at running gears on Flywheel's scalable compute platform. So what is a gear? Simply put, a gear is an algorithm, along with its dependencies, packaged into a Docker container so that it can be run on Flywheel. Now, because these algorithms are containerized, that means they can be executed in a reliable and reproducible way, regardless of the computational environment. We offer a number of pre-built gears through the Flywheel Gear Exchange, everything from basic utilities to QC to pre-processing and pipelines. Or you can easily build your own custom gears and upload it to your Flywheel instance for use by users at your institution. You can also, if you choose, share it with the wider Flywheel community through the Gear Exchange. Now, there are a number of ways to run gears on Flywheel. One of the more powerful tools we offer is automation through gear rules. For example, on this project, I have a set of gear rules that will be executed on incoming data. First, I have a rule that says for any incoming file of type DICOM, I'm going to run my DICOM MR classifier gear. Now, in this example, I'm using MR data, but we have support for multiple modalities and data types. The second rule I have will look for my DICOM, and after it's been classified, it's going to run a DICOM to NIFTY converter. Finally, I have a rule set up that will look for a NIFTY file, and if it is a structural, functional, T1, T2, or T2 star image, and it's not an in-plane image, I'm going to assess the quality by running MRIQC. So let's see how this works in practice. For this demo, I'm going to upload a DICOM using our web uploader, but we'll see the same behavior if it is an image coming directly from a scanner or through our command line tools or SDKs. Back to my project, I see my newly created session. If I click on provenance, I can see a comprehensive log has been created that details the gear version and tracks my inputs and, of course, outputs. So for data coming off a scanner, we've de-identified it, we've classified it, we've converted it to NIFTY, and we've run QC. A process that typically takes hours instead is reduced to minutes with Flywheel. I can also run gears manually from the UI. As this dialog shows, we have two basic categories for gears. Your utility gears are for basic tasks such as file conversion, classification, and QA. Then, of course, we have analysis gears for segmentation, pre-processing, and pipelines, and so forth. So if I want to run fMRI prep, I'll be prompted for my inputs. I can select my license file, which is attached to my project. I can select my NIFTY. I also have a host of configuration options, everything from bids validation to controls on my outputs. It's also important to note that I can select which version of the gear I'd like to run. Here I'm running the latest version, click Run Gear, and my analysis job has been kicked off. Now, what you don't see in the background is how the Flywheel infrastructure is requesting scalable cloud compute resources to meet the demands of my given job. This means that Flywheel can automatically scale to support compute-intensive analysis running in parallel. And with my analysis job complete, I can see that we have a discrete analysis object that has been created here in the Analyses tab. I've referenced all my input files as well as my outputs, which I can view and easily download. I can leave notes for collaborators as well as view complete information on gear and algorithm version, everything I would need for reproducibility. So in summary, there are a number of advantages to running gears on Flywheel. Because gears are containerized, they can be run in a reliable and reproducible manner. We further support reproducibility by providing comprehensive provenance. All of your inputs, configurations, and outputs are tracked in your Flywheel projects. Additionally, you can easily share your methods with collaborators potentially across the globe because your algorithm is containerized. Any user on any Flywheel instance will get the same results running the same gear on the same data. We also give you scalability. Whether you have Flywheel installed on Google Cloud, AWS, or Azure, Flywheel will orchestrate the allocation of cloud compute resources as needed by a gear. Finally, our rules framework makes it easy to automate pre-processing, QC, all the way to full analysis pipelines. This saves time and reduces the risk of error or data loss. And that concludes my overview of gears on Flywheel. For more information, please visit us at www.flywheel.io. Thank you.